All right, since everyone is excited to be here and paying attention, ain't no damn way someone is on their phone during my class, especially during my instruction right now. Because we all like to see you. Everyone's amazing. You're awesome. Okay? No matter what your mom says about you. So, class? Yes. Thank you. Okay? Now, let's go through here. 1.4, limits, continuity, trigonometric, exponential, and logarithmic functions. A lot of people have trouble with most of these things. Okay? When I say trig, you guys freak out and start having a seizure because you don't really understand how easy trig is. Okay? It is. So you just have to have a relationship with it. You have to have an understanding of truly what it is. And then it's not so bad. It's really not. We used to have a class here on this campus that was trigonometry. And guess what? That used to be the lowest class that we had here on campus. It is College Math 187. It's above College Algebra. College Math is 142. College Algebra is 151. Trigonometry is 187. But I taught trigonometry to every single student coming through here because that was the lowest level math class we had. And guess what? We had the highest passing rate and the highest percentages throughout the district. Because people don't understand it, so they get mad and upset. Yes. Because our students were doing too well and they understood math. There you go. All right, squeeze theorem. Suppose function f and g and h have properties for all x in an open interval containing c except possibly at c. Now, what we do is basically saying that if the left side less than equal to, okay, this is my left, is equal to my right side, then left side and right side of whatever my function is, so I have the limit of the left, limit of the right, so whatever it is in between there is going to squeeze into that limit. Because sometimes we cannot find the limit at the function, we use the squeeze theorem to actually show that we could actually get that in between using smaller and smaller items. Get closer and closer to that number from both sides. Okay, find limits involving trigonometric functions, theorem between two basic trigonometric limits. Suppose the functions f, g, and h have the property for all x in an open interval containing c except possibly at c. So the limit as x approaches 0 for sine. So imagine in your mind, so right now, picture the unit circle. Okay, you can close your eyes if you need to. Picture the unit circle. Where is 0 on that unit circle? All the way to the right. Okay. Now, if it's all the way to the right, what is the coordinate over there all the way to the right? 1, 0. My x value is 1, my y value is 0, isn't it? And what did I say that x value truly represents? That's your cosine. And the y value represents your sine. So I could say, just thinking about it, that if I imagine the unit circle, I find that point over there, so the sine at 0 is the y value, which is 0. So if you imagine unit circle again, now, where is pi over 2? Where's pi over 2? Straight up, isn't it? Okay? The coordinate, if it's going straight up, it's going to be 0, positive 1, right? The y value goes up 1. So that's 0, 1. So I imagine, okay, so if I know that the x value is my cosine, the cosine going straight up is going to be 0, and the y value is now 1. So, in between those two, find the limits involving these. So right here, We just did that to imagine what is happening in between those two. Find the limit of a trigonometric function. Now, can I plug in 0? No. Okay? Now, you want me to show you guys how to cheat on this? There's an identity. There's an identity, sine of x over x. What do we get there? As the limit approaches 0, this is something I think I gave you guys. I know we have to, it was actually one of the papers. I think it was your Unit P papers now that I think about it. And I said, hey, this is super important. Is it the homework? Okay. And one of them, and it said, okay, that gave us what? That gives us what? This is an identity. So we're going to use the crap out of this identity. Sine of x over x. Limit as x approaches 0. Can you plug in 0 into there? No, because that would give me undefined. But we're going to use that one, and I'm going to make that one there into that one. What's missing on this one, that is there. The 3, right? Okay. So what can I do? I'm going to multiply by the value of 1. You guys remember doing that? Multiply by the value 1. But if I multiply by the value 1, my 1 is going to look funny. What value of 1 do you think I should use? What did you say is missing? 3, where? In the bottom, right? So I'm going to multiply by the value of 1, but it's going to look like what? 3 over 3. So I'm going to say the limit as x, oh, I'm sorry, that's theta, approaches 0 of this, and I'm going to go 3 over 3. What's up, my dude? How are you doing? Oh. Sure, take it. Do you want a secondary one? One of my engineering kids, do me a favor, go in the back and go grab the box fan over by the wood storage. Yeah. Okay. Yeah, no worries. Okay, so right here. So now do you guys understand where the 3 comes from and why I use 3? Anyone question so far? All right. So I'm going with it. Now, if I multiply this, I'm going to say that this is now going to turn into the limit as theta approaches 0 of 3 sine 3 theta over 3 theta. So, what's going to happen right there? That whole thing right there equals 1, right? This is going to equal what? And this right here says it's going to be 3 times all that. So my answer now is going to be 3 times 1, which is That's super crazy. You guys just learned an awesome identity. Now, you people, I know you guys are pretty smart. Use the same thing I just taught you, but do it for B. Only one, because you're not changing the value. And you could use one of the rules that we talked about the other day about limits. All right. I know you guys are probably getting stuck here. So what? You could, but you're dealing with multiple variables and don't do that. So when we're talking about identities, yeah, that's fine. You can actually change up that whole thing. It'd be just your x and y when you're looking for the coordinates or the unit circle from line. So when the properties, if I have a division, I can divide it. I can just say the limit of the top divided by the limit of the bottom. Can I plug in 0 directly? Say no. Why? 0 in the denominator, right? Okay. So what am I going to do for this top one right here? Close. Yes, because you can break it up into the limit of the top divided by the limit of the bottom. So by treating it as separate equations here, I now could look at it as it's going to be the limit as theta approaches 0 of the top, which is going to be sine 5 theta over 5 theta, and this is going to be times 5 theta all over limit as theta approaches 0 of sine 2 theta Now, what's going to happen to my sine of 5 theta over 5 theta? That gives me 1. 1 times 5 theta is 5 theta. Sine of 2 theta over 2 theta? That gives me 1, and left with. So, my answer is? Nope. 5 over 2, because what's going to happen to my thetas here? I have a theta on top and bottom. You want to make it into the identity of 1. If I made it to 0, what would happen if I tried to turn it into a 0? The bottom is always going to give me 0, isn't it? And I can't have that. Please excuse this interruption. Attention all students. All right, go back. Sorry about the interruption. Okay, go ahead. Where are you at again? Okay, what is 5 theta over 5 theta? What's 5 theta over 5 theta? 1, right? So if I multiply anything by 1, do I change the value? We're just changing the way it looks. We're not changing the value. Because I'm trying to get it to be this. I have to try and get it to that because I know that the limit as x approaches infinity of this, both of these have to be the same, to equal 1. Okay, no worries. All right, yes, Blake? Denominator and numerator by 2. So you multiply by, but the problem is for the identity to work, 2 over 2, now watch this. Blake, you ready? So that means you're only working with this right here. What's the limit as theta approaches 0? Here, plug in 0 into this. What is 2 times 0? What is the sign at 0? 0. Can I have 0 in the denominator? That's why. So yeah, so you have to make sure that you see that you cannot have 0 in the denominator. So I am trying to work around having that. Question? Is that good? Anyone else? Are we good? All right. So what time we have here? 20? No, 10. Okay. So let's see. That means this is going to be our next one that we're working with. So make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store, right? And don't forget, 1.3 is due, what did we say, tomorrow?